Okay, so welcome back, and in this video we're going to be taking a look at mostly calculations associated with the change in entropy of the surroundings. So what we need to remember is that the change in entropy of the system is typically looked at qualitatively. Now, it's not to say that it cannot be actually calculated, because it can. You just need to have absolute entropy values, which typically would be provided in a table. And often a large determining factor for the change in entropy of the system is going to be the sign, obviously, which will be determined by the behavior of gases in the reaction. So in other words, when you are increasing the number of gas parts as you go from reactants to products, you are going to have an increase to the entropy of the system, which means a positive value. And if you're decreasing the number of gas parts as you move from reactants to products, then you're going to have a negative sign for the delta S of the system. So more gas parts equals positive, whereas less gas parts means negative. On the other hand, the delta S, or change in entropy of the surroundings, in the reaction is something that you can calculate given a balanced equation. Its sign can also easily be determined by looking at the enthalpy for the reaction. So for example, if we take a look at this equation here, which is what we'll use to calculate the value for the change in entropy of the surroundings, we can go to this example problem here and see automatically that with a positive enthalpy, that the change in entropy of the surroundings is going to have to be negative, because temperature is going to be in Kelvin, which means it can't be negative. So if the reaction provided here is run under standard thermodynamic conditions, what would be the change in entropy of the surroundings, and is the delta S increasing or decreasing? So this is a two-part question, because remember that delta S here as written really means delta S of the system, because when you don't see a subscript for the term, you can assume that they're referring to system. So with that in mind, let's take a look here. Let's deal with the first part of the question. So delta S surroundings is equal to opposite delta H over T, which means that we are looking at opposite 341.4, and that's kilojoules. So if we're going to make this work out, we probably should convert this to joules, and then divide it by, and in this case, 298. And so taking a look at this, we've got 341,400 divided by 298, and so that would be negative 1145.6. Probably carrying too many sig figs. Based on this, we're looking at probably more likely 4 or 3 sig figs, so thinking that we could report the answer as negative 1150. No decimal point, actually, so negative 1150 joules. And so that's going to be the change in entropy of the surroundings. Now when it comes to the change in entropy of the system, remember it's going to be the gas parts that's going to be the main determiner. If there is no gas, then there are other inspections that you can make, but gas parts is going to be the biggest determiner. And here we have 2 gas parts plus 2 gas parts means 4 gas parts, and then over on this side we have also 4 gas parts, which means that the change to the entropy of the system is going to be predicted to be in the neighborhood of 0. So there's really not a benefit. We can't use the equation as is to help us predict a sign for the change in entropy of the system. That being said, with a negative value for the change in entropy of the surroundings and a essentially no sign value for the change in entropy of the system, we're probably thinking that this process is going to be spontaneous in the opposite direction. And if you need some help with figuring that out, you can check out the presentation on change in entropy of the universe. But I hope this helps in terms of making a calculation for change in entropy of the surroundings. You can use your delta H value and divide by T. Now in this case, clearly we didn't necessarily need to convert to joules. It was just a decision that I made. In this case, you could go either way. When a sign is provided to you, that's when you're, or not a sign, but a unit for what you're calculating is provided, that's what you're going to want to match up with. So, hope this helps. Good luck putting it to use in your problems.